Okay, I'm going to go over the complexity analysis for merge sort. So first I'll go over the algorithm. We have at the beginning a check for a base case. If n is small enough, less than or equal to 3, we'll sort it using something arbitrary, for example, global sort. And then we will recurse over the left half and right half of the array we want to sort, sorting each of them recursively. And then we will combine those two results into our sorted array by putting them side by side, comparing the smallest elements, and picking the smaller one, putting it into our new array until we're all the way through each of the list, which will be a linear iteration over the two halves. All right. Now, to analyze the complexity of this, we first check how the recursive calls build up. So let me draw a diagram. We have our original call, which I'll say is T of n, for T is the time complexity of a merge sort call in an array of size n. That will branch out into two recursive calls of half the size, call it T of n over 2, and then each of those in turn give us recursive calls of half the size of those, which is a fourth of the size of the original problem, and so on. And eventually, we'll get to something which is basically a constant. It'll be the base case. All right. Now, how many levels do we have? If this is level 0, 1, 2, we are dividing the size in 2 each time. So the number of levels will be log base 2 of n. So this is log base 2 of n. Right. Then we need to analyze what is the time complexity of merging, combining the two sorted subarrays, which is this section from here until here. Now, since we simply iterate over the left half and right half once overall, which you can see is here, here, and here, and those three places combined to iterate over each of the subarrays once over. So this is just O of n. And we have an O of n for every recursive call. So in this top level, we'll have a single O of n call. In this second, in level 1, we have 2 recursive calls, each of size n over 2. So we have 2 O of n over 2. In the next level, we have 4 O of n over 4. This is supposed to be a 1. So overall, this gives us the sum. If we sum over the levels, we have the runtime of a merge sort on an array of size n is the sum of the runtimes over each of these levels. So if we call that level k, it starts from 0 and goes until log base 2 of n. Then in each level, we have 2 to the power of the level, O of n over 2 to the power of the level, which is simply O of n each time, since the 2 to the k's will cancel out. And this leaves us with O of n times log base 2 of n. Since there's no more k in the summation, we just multiply it by the number of terms in the summation. Right, and that is the complexity analysis of merge sort.